Okay, Raiders, let's review how to take something that's launched at an angle and break that velocity down into its x and y components so that we can then use it in equations in the x and y direction. So let's say we've got a ball that's being kicked 28 meters per second, and let's say it's at a 60-degree angle. So in this situation here, since velocity is a vector quantity, you can't take this angled velocity and put it in an equation with horizontal values, like if you're trying to find the range of the ball, or vertical values, like with acceleration from gravity pulling straight down. So you have to break this up into the x and y components. So again, just our little reminder about SOHCAHTOA is just a little saying to remind us about what combination of side lengths we can set up as ratios to divide, whether we're dealing with sine, cosine, or tangent. So take that angled velocity and set up a right triangle with it. That if something's kicked up and to the right, equivalently, it's going a little bit to the right. We'll call that Vx. And it's also going a little bit initially vertically upward, Vy. And the overall velocity is 28. So now we have a right triangle situation with this 60-degree angle. So now we want to get these x and y components. So relative to this 60-degree angle, this launch angle, the 60-degree angle to the horizontal, relative to this angle, Vy is the opposite side, Vx is the adjacent side, and the overall velocity is the hypotenuse. So identifying these side lengths relative to the 60-degree angle, that's going to help us be able to use our little SOHCAHTOA reminder here about which trig function is appropriate. So if we want to get the y component, it doesn't matter which one we get first. If we want to get the y component relative to the angle we're working with, this is the opposite side, and we know the hypotenuse. So that combination of opposite and hypotenuse, if you look at SOHCAHTOA, is sine. Opposite divided by hypotenuse. So that's how we know to set up sine of 60 degrees equals. Now set up the ratio that the SOHCAHTOA reminds you of, the opposite side length divided by the hypotenuse. Well, the opposite side, that's our unknown. That's what we're looking for. So it's Vy over the hypotenuse, which we know is 28. So this is just an algebra problem now. Our unknown is right here, v sub y. We want to isolate this variable, get it all by itself. Well, if it's being divided by 28, we have to undo that. So the inverse or opposite of dividing by 28, multiply by 28. So golden rule, you have to redo to one side of the equation and do the other. So multiply both sides by 28. So Vy, the vertical component of the velocity to start out, now you can type this into the calculator just like you see it. So 28, you don't even need to do the parentheses or the multiplication. 28 sine 60. So approximately 24.2 meters per second. So this ball is going to behave vertically, the same as if you just kicked it straight up at 24.2 meters per second. Now let's get the x component. Well, relative to the angle, the x component, Vx, is the adjacent side, and we know the hypotenuse. Well, looking at SOHCAHTOA, that combination of adjacent and hypotenuse is right here. Cosine is the ratio of the adjacent side length to the angle divided by the hypotenuse. So that sets us up for cosine of 60 degrees equals Vx over 28. Multiply both sides by 28. So Vx is approximately, so 28 times cosine of 60 degrees, and we get 14. And that was an exact value. So let's just think about these components for a second and why they make sense. If you notice, the y component is much larger than the x component. And that should make sense because if the ball is launched at a 60-degree angle, it's closer to vertical than horizontal, so the vertical component should be higher. So in terms of moving forward, depending on what was asked in this problem, anything where you're analyzing the horizontal motion of the ball, this is the velocity you're going to use, and it's going to be constant because it's not impacted by gravity at all. And then if you're analyzing anything about the vertical motion of the ball, you'll use this as the initial velocity, because the velocity is going to change over time due to gravity. All right, hope that helps. Have a good day.